Unit 4, Graphs, Functions, and Their Applications. This lesson will be about interpreting algebraic graphs and actually understanding the variables between an x and a y. The reason we use the words x and y in this is the x-plane is the xy plane, which is a two-dimensional plane. Left to right is the x, and up and down is the y. The first component, you see everything here in parentheses, is the x. The second one is the location of the y. So if I was going to look at, if I go look at to see the 3, 6 towards the top of this sheet, of this graph, 3 is 1, 2, 3. I look to the right. I start at the point of origin, and this is the origin where the 0 is. I go 1, 2, 3. So that is 3 right here, and that's the x, which is this one right here. Then I go up 1, 2, 3, 4, 5, 6. So the coordinate for this is 3, 6. And this is for an equation, y equals x plus 3. And I've put every number in for y equals x plus 3. I got negative 3 plus 3. I get a resulting 0 for y, which is right here. Negative 2 and 1. I put negative 2 plus 3, so negative 2, and then I add 3, I get 1 right here. And we can see, you can go through all these, but I matched the equation to the points on here, so I wanted to show you. Similarly, this is a parabola. We'll be studying more during quadratics. But y equals x squared. So what happens is, every time you square something, it becomes positive. Negative 3 squared is 9. And we got this point right here. So y equals x squared, negative 3 is x, negative 3 squared is 9. And I got 3 squared is also 9. That's the reason we have this parabola here. But again, we're looking at the x and y coordinates. So I want to be able to interpret this. And remember, it starts over here at this point at 0, 0. And that is called the origin. Now this slide is very similar to the previous one, another parabola here. But you noticed the equation is slightly different. Y equals x squared plus 2. That's the same shape. But that plus 2, you can see right here, what's happening is it moves it up 2. This plus 2 here moves it up 2. I got another parabola here. And it's a more complicated equation. It's y f of x, which is the same as y. F of x equals x squared minus 2x minus 3. And I've solved for every one of these equations. I just wanted to show you. If I put in negative 3 for x squared for negative 3 is 9, negative 2 times negative 3 is 6, and then negative 3 is 9 plus 6 is 15 minus 3 is 12. So our final answer, when x is negative 3, f of x is 12. And when x is negative 3, go here in the graph, here's negative 3, here is negative 3 and 12. And I've done that for all these. But as you can see, we can take an equation that we write up in a mathematical line and turn it into a graphical component that makes perfect sense. Every one of these points I found with the equation corresponds to this graph here, as you can see. Now, one thing we're talking about is the domain and the range. The domain are basically the numbers in the x. The range are the resulting numbers in the y. Whatever you put in for x, you get a result with y. Now, if we have a series of points, domains and ranges, again, x is the first number, y is the second number. All the domains are 1, 2, and 4. Those are my x's. All the ranges are 3, 5, and 9. Find a range of equation where f of x equals 3x plus 6 with domains are 1, 2, 3, 4. And when I put in 1 in 3x plus 6, that's 3 times 1 is 3 plus 6 is 9. 3 times 2 is 6 plus 6 is 12, and so on and so forth. I found my domains, found my ranges. Find the domain where find the domain of f of x where equals 2x plus 1. Then my domain can be any number, and we call these all real numbers. It can be negative 10, it can be a million, 225, 1/4, it can be all the real numbers. Now, when we look at a linear equation, we can determine a lot by looking at the equation and for what is shown in the resulting graph. I've got an equation here, and this is the line for it to the right here. The equation is f of x equals 2x plus 9. What you see here is a thing called the y-intercept. Remember, my vertical axis, my up and down axis, is the y-axis. And really what we're looking for here is the y-intercept. It's where a line for an equation intercepts the y-axis. And in this case, it intercepts at x is 0, y is 9. And that can be found. If I put in f of x equals 2x plus 9, if I put in x for 0, which is a 0 there, 2 times 0 plus 9, and what do I get? 2 times 0 is 0, all left of this is 9. So I put in x, my f of x is 9. X for 0, f of x is 9. And this is where it intercepts the y-axis, called the y-intercept. Here's another one. My intercept, I can look at the equation, I'm not even doing anything. It is 0, 4. There's my 4 right there. So I put in 0 for x here, y equals negative 5 times x, with negative 5 times 0 is 0. So I end up being y equals 4. And look where it is, right here. It intercepts at 0, 4. Now, the y-intercept is part of a linear equation we can find. The other part is the slope. The slope is the rise over the run. It is the angle of something. It is the y over the x. How many pieces of y over how many pieces of x? And I can tell you something here. It's pretty interesting. You look at this equation right here. F of x equals 3x plus 2. Well, there's my y-intercept, as we've learned. I'm going to put int here. It's hard to write with this. A y-intercept. Here's my slope. It's 3. Because that's 3x. Wherever the x is touching, that 3 determines it. And I've written this equation as before. I showed you all the points here. And I drew them all. But more importantly, if you notice, no matter where I go in the line, if I find a certain point, and I go on this one up here, it's the y's over the x's. I go 3 up, it rises 3, it goes across 1. 3 over 1 is 3, the same as this 3 right here. I can go bigger. If I go 6 up where the line starts, then I go 2 across right here. 6 over 2, rise is 6, run is 2, equals 3. And we can find the slope by finding any 2 points. But with this equation right here, y2 minus y1 over x2 minus x1. And let's find 2 points here. And I've got here 11 and 3. So this would be, it would look like this. 3, 11. And then the other one is, the other point is -7 and -3 here. And that would look like -3, -7. And we just have these 2 points. You can do any 2 points on a line. We'll use these 2 points. I subtracted, this would be my second part. This is my second part here. My second point, this is my first point. So this is my x sub 1, my y sub 1, and 1 is the first point. Here's the second point, x sub 2 over y sub 2. And if I take this equation right here, y2 minus y1 over x sub 2 over x sub 1, I put 11, right here, 11 minus negative 7, which I've written right here. 11 minus negative 7 is the same as 11 plus 7, two negatives making a positive. That's 18. Then in the denominator, it's the x2 minus x1, which would be 3 minus negative 3 here, which is the same as 3 plus 3. And I get 6. 18 over 6 is 3. So we look at 3 ways we can find this. We can do it graphically, we can look at the equation, or we can find 2 points. And it's the same 3 as that right there, and also as we see the slope right there. Now, I can just give you 2 points and find it. 8 over 7 and 2 comma minus 1. We'll call my first point is x1, y1, which is 8 and 7, x2, y2, 2 comma minus 1. Those are the coordinates. y2 over minus y1 equals x minus x1. Let's just plug in this equation right here. So my y2 is negative 1, my x2 is 7, negative 1 minus 7 is minus 8. My x2 minus x1, 2 minus 8 is minus 6. Minus 8 minus 6 can be simplified to plus 4 over 3, because negative over negative. So my slope is 4 over 3. And if I look at any 2 points, let's do the 8, 7, 2, 1. The 1, if I go up, 1, 2, 3, 4, 5, 6, 7, 8. And then when the line meets again, go across 2, 3, 4, 5, 6. It's 8 over 6, which is 4 over 3. And that is how we find the slope and how to interpret the slope.